So what we're talking about today is going to be physical and chemical properties and physical and chemical changes. So I've got a lot of stuff here that I'm going to be doing a demonstration with, and we're going to determine if it's a physical change or a chemical change. So I've got some stuff back here that I want to remind you about. If you watched the video on physical and chemical changes, the notes, then you already know about this, but we're just going to review this concept really quick. So remember that a physical change is going to be a change that results in no new substances. So in other words, nothing new is being created. The original substance still exists. And a really good example of this is going to be a phase change. So right behind me here, we have the states of matter. So when something undergoes a phase change, it's still the original substance. For example, when I have ice, which is a solid, melts and turns into a liquid, it's still water. If it evaporates, it turns into a gas, it's still water. So that's a physical change. The original substances still exist. When something undergoes a chemical change, that means that a new substance has been formed. The chemical bonds between the molecules that originally existed break, and they go and they make new chemical bonds with other atoms. Okay, so the original atoms are still there. According to the law of conservation of matter, or the law of conservation of mass, the matter is still there. The atoms are still there, but what they do is they rearrange themselves. So I always think of it as like, you know, a boyfriend and a girlfriend are together, but then they break up and they start dating somebody else. So they still exist, the atoms still exist, they're just rearranging themselves. And we can look at different bits of evidence to show that something is a chemical change. And that's what I have over here. We have indicators like an unexpected color change, an unexpected temperature change. Something gets cold or hot unexpectedly, okay? Not like I put it on the stove and now it's hot, that's expected. It has to be an unexpected temperature change or an unexpected color change. If I put food coloring in water, that's still the original substances. It was an expected change, okay? Formation of a solid, which is a precipitate, that's evidence of a chemical change. A gas production, something there's a gas there that wasn't there before. That's a chemical change. I have some more examples over here. So very similar, a change in smell or odor. Light has been created. Think of like a glow stick. When you break a glow stick, there's two chemicals that are mixing together and light is created. Change in temperature, like I said, a sound is produced, like an explosion. Gas created again, heat created, and any new substance like a precipitate, like I mentioned over here. So what I'm gonna do now is I'm gonna zoom in and I'm gonna give you some examples and we're gonna determine if it is a physical change or a chemical change. For our very first demonstration, I have a candle right here. And you can see that it's a wax candle and it has a wick. So I'm going to light it, not for very long because our fire detector is very sensitive, but I've got a candle burning now. And the wick, okay, is burning. So is that gonna be a physical change or a chemical change? I want you to think about that for a minute. Now, what is the evidence that it's a physical change or a chemical change? So we're talking about the candle wick first. Now, if you notice, you can see that the wax is melting. The wax is melting. So that's a phase change. Is that going to be a physical change or a chemical change? Now, with the candle wick, a new substance is being formed and there is a reaction. So the candle wick burning is going to be a chemical change. The wax melting is a physical change because that's just a phase change. It's still wax, but it's melting. The original substance still exists. So the wick is a chemical change while the wax is a physical change. Hopefully that doesn't set off the fire alarm. Okay. For our next demonstration, I have some vinegar here in this bottle. So just regular vinegar that I have from here. And then I took some baking soda and a funnel and a spoon, and I put baking soda into this balloon. And so what I'm gonna do is I'm going to carefully place the balloon over the bottle. And then I'm gonna take the balloon, so you'll notice that there's baking soda in here. I'm gonna take the balloon and I'm gonna flip it over. And the baking soda is gonna fall into the vinegar, okay? So here we go. Oh, I think I have a little hole in my balloon. So what you can tell from here is that a gas was produced. Okay, here's our balloon full of gas. Now, was this a physical change or a chemical change? Okay, physical change or a chemical change. So this was a chemical change. What is our evidence that this is a chemical change? What you should have answered is a gas is produced. So this is a really good example of the boyfriend and the girlfriend breaking up and the atoms rearranging themselves. All of the matter that was here in the first place is still here. It just changed forms, it just rearranged itself. And some of it is now a gas. If I were to take the mass of the baking soda and the vinegar before the reaction, it would equal the mass right now after the reaction. There's no matter that appeared or disappeared. The atoms just rearranged themselves. Our next demonstration involves steel wool. So this is steel wool right here. Some people use it to clean off things like metal, and it scrapes paint off of metal and things like that. So this is steel wool. And what you can do with steel wool is you can put it in water or vinegar and it will rust. So a couple of years ago, I put some steel wool into this little bottle with some vinegar, and this is what happened to it. It rusted. So is this a physical change or a chemical change? And what is your evidence for this? This is actually a chemical change, okay? We know that it is a chemical change. Rusting is always a chemical change, but why? The reason that rusting is a chemical change is an unexpected color change. So rusting is an unexpected color change. It is a reaction. A new substance is being formed. The atoms are being rearranged. The reaction is called oxidation. And that's what makes it turn red. The next demonstration that I'm going to show you is actually going to be a video that I'm going to insert here. And it is a lead iodide reaction. So lead iodide, you're mixing two clear liquids, and then there is an unexpected color change. So is this a chemical change or a physical change? Lead iodide is a chemical change because it is an example of a precipitate forming. So you'll notice that the yellow precipitate is actually falling to the bottom of the test tube, and that's because it's more dense. It's a solid, which is a precipitate. A new substance has been formed. There was a chemical reaction. For our next one, Miss Bettis is helping me, and I'm going to pour a mystery substance into her hands. And then I'm going to add water, and we might spill a little bit, but that's okay. And so what this is instant snow, and you can feel it. So before it was very granular and it absorbed the water and turned into fake snow. This is the same stuff that you find in diapers. And what happens is it absorbs the water. So is that a physical change or a chemical change? It just absorbed the water. There's no new substance, so that's a physical change. Here is what we end up with. This is our instant snow. I have these tablets, and I'm going to drop it into the water. So do you think this is a physical change or a chemical change? I can see that a gas is forming, which is a new substance. So that is a chemical change. And my evidence is a gas forming. For our next demonstration, we have two polymers, which are basically plastics. We have polymer A here, which looks kind of like syrup, and it's got a syrupy consistency. And then we have polymer B, and then I'm going to add it to polymer A, and then I am going to mix both of them. You'll notice that they do have a difference in density. Polymer A is more dense than polymer B. So you'll see polymer A, the darker one, actually sink to the bottom or stay at the bottom, and then polymer B will actually float on top of it. You can kind of see it right there. So what I'm gonna do now is I'm going to mix them together. So you'll notice that they're both in there. I put equal parts of each one, and now I'm going to start mixing. You have to mix very vigorously. Miss Bettis is here watching, recording with her camera, and she has never seen this reaction. So you'll notice that something is happening now. And we definitely have more than what we had before. So this is the magic foam reaction. And I'm going to use my popsicle stick to kind of hold it steady. I included a lot of chemicals in this one today. And if you were to be able to feel the cup, which we would normally do in class, you can actually feel that it is pretty hot. So it's actually an unexpected temperature change. So that's our foam experiment. And if once you let it cure, it's actually hard. Demonstrations for physical and chemical changes. I hope you guys enjoyed this video. I'll see you guys later. Thanks for watching.